All right. Live on YouTube. Dude, frickin' I need to figure out this OBS thing. Or the, how to get the dock in my OBS to update the frickin' YouTube chat. I need to redo it every time, and it's so annoying, so I can only do it while I'm live. Okay. I think I'm all good on YouTube, though. All right, let's get into it. I'm getting slightly faster at this now with getting YouTube going. Mic is coming through. Okay. Oh God, I need to get this off my stream because it's gonna. Okay, there. Actually, no, it's not good. Like that. Okay. I can see my own stream in a little like YouTube preview, and it was like distracting me. It's like, oh, what's happening over there? But then it's just me. I don't think I have anything to add onto this one. This person is just asking kind of in general how a derivative and integral works. They said thanks. Okay. Let's move on. Let's look for new questions. Hey, Zach. Yeah, no. I mean, to be fair, you've rated me like a million times, so you know, I hope you don't feel obligated to keep on rating me. I'm kind of, I'll say, I don't mind at all that like you'd have to just rating shock. I do really appreciate it though, but yeah, at least you know, I think we've already like rated like back and forth a ton. So you know, if we miss one day, it's not the worst thing in the world. Do you eat? Do you have to eat? All right, no worries. Thanks for popping in at least and for thinking of me, even though I was being late. Enjoy your food. You won't be here much, honestly. No worries at all, Zach. You probably already spent a good portion of your Saturday doing math, so go enjoy it. Or go enjoy like the rest of your Saturday. Four hours today, a new math record. Nice. That's a lot of math. Oh, did you say that? Okay, well, if you need to leave, it's completely fine. Like, don't stick around because I'm asking you a question. But if you do happen to be around, do you say that you're going to announce something today? It like just occurred to me before I went live. And again, if you're going to go eat, don't feel free to completely ignore me. So they have data and they want to guess what the true average is, which is like very much in the wheelhouse of a normal stats problem. I hope I'm not misunderstanding them. Let me find like maybe a resource I can help them more than confidence interval. Confidence interval. I was thinking of doing like Z or normal, but if I just generally look up confidence interval, it should be good enough. It's not a very good like first introduction to confidence intervals. This site usually has very good like introductions to topics. Yeah, so we can give them this as a resource to get them started. Given level of confidence. Thankfully, this is a question. This is a very common thing to do in a stats class. I would recommend you look up confidence intervals. Here is a helpful website to get you started. In your situation, you can use the normal distribution since the sample size is big. Confidence intervals can also be done with other distributions, but they shouldn't be needed for your situation. Oh, do they want to make the interval first and then get the level of confidence after? Ooh, okay. So, I mean, I think that's still pretty possible. It's just... that's actually not really the way the confidence interval works now, is it? Mm. Okay, I want to say that there's two different interpretations of this question. How do I say that in like, I guess, a clean way? choose a level of confidence, then use your sample to get an interval for the true average of the population. This is the case. The other interpretation that I'm seeing is the backwards version, where you want to force the interval to be between 0 and 5, and then calculate your confidence level for that interval. I think it would just take some normal algebra. I think it could definitely work if your sample happened to have an average of 2.5, halfway between 0 and 5. Do some algebra with, since I don't say just do it, since you could do some algebra with the formula for a confidence interval above. If your sample doesn't happen to have an average 2.5, then it becomes an unusual stats situation that I have a hard time giving advice on. All right, I think that's the best that I can do for him. I didn't even look at the stream information for the YouTube stream. Live chat replay, anyone? Okay, good. Stream information is basically fine. More or less. It seems like it. Oh, dang. Oh, no, that's the thread I was just looking at. Confusing solution. Because since they don't have the sharpest knife in the drawer. Ed already has an answer, though. I'm getting paranoid about the YouTube stream again, because the YouTube stream is super weird. I'm like, I'm still like getting used to it. Okay, no, it is indeed live. Okay, so the audio was coming through twice for a second, but you've had some weird things that I'm not used to, so I just want to make sure that I actually was live, because on Thursday I thought I was live for like 10 minutes, and then I realized I wasn't. Okay, this one doesn't have an answer. Assume the idea of the radius of the circle is equal to the reciprocal of the curvature function. Osculating? Well, I haven't heard of this. How do you pronounce this? Oh. Okay. So it's just you draw a circle that kind of fits inside the curve, basically, as the same tangent line. I can think of a very long way to calculate that given the equation of the tangent line. I wonder if I feel like there'd be a shortcut though. Osculating plane. Oh, okay. And I guess an osculating plane could be the same exact thing, but with a plane. All right, here's up. Okay, let me run pronunciation. Do you saw the O? Okay. Osculating. Okay. I feel like you weren't supposed to pronounce the C, but. So we need the center and the radius of the circle. How would you get the? Yeah, actually, the radius could be anything, couldn't it? Because there's infinitely many circles with the same tangent line, so. Curvature of the circle is going to be 1 over r. I guess it's how they're making it so it's only one circle. I don't really understand the curvature of the circle, like what that actually means, but I can follow the math if I just accept that's true. So do they have it? Okay, so this is only 2 dimensions, but it's not solved explicitly for x or y. It's interesting. This is something that's new to me. So the curvature, kappa. So I bet we could still find f double prime and f prime, even though the f function isn't defined explicitly. And that's probably what the question's about. I think. Yeah, so I think that's exactly what their question is about. So let's see if we can get f double prime and f prime x solved for explicitly. Actually, we don't even necessarily need to solve them explicitly. We just need to plug in the x and y coordinates. Okay, so yeah, I think I know what to do here. I haven't done an oscillating circle. I never even heard of it before, but I think I get the general idea. If I just hand wave away some parts of this. Let's do green. We don't do green enough. So we have x squared plus 15xy. Plus y squared. It's equal to 17. It's not really relevant, but like, just out of curiosity, that is factorable, I guess. It's not. We don't really want to factor this, I don't think. But it's kind of fun to think about. But anyway, so we want dy by dx here. We're gonna have to do some implicit differentiation, but that's completely fine. So x squared just becomes 2x. 15xy, we have to do a product rule for. Let's derive the x first, so we'll get 15y. Other part of product rule, we'll derive the y. 15x, y derives to 1, but because it's y, we have to do dy by dx for chain rule. Then we have y squared, that becomes 2y, and then same dy dx because of chain rule. And 17 derives to 0. And now, we could solve it explicitly for dy by dx, it wouldn't be that hard, but we don't have to do that much work. Let's just plug in 1, 1, because that's what our point is. So 2 times 1 plus 15 times 1 plus 15 times 1 dy dx plus 2 times 1 dy dx equals 0. Solve this for dy by dx. 17 dy dx, that's kind of funny how that works out, is equal to minus 17. So dy dx is minus 1. That's the first part of the equation. We need to get d squared y dx squared now. So we're going to have to derive this again. Actually, what happens when you do dy by dx of dy by dx? I don't actually know, to be honest. Actually, it's just d by dx. That makes it a bit clearer to me. It's not actually dy by dx, it's just d by dx. Does it make it clearer, though? dy by dx is just, yeah, okay. I'm gonna like tripped up on the notation here, but just to write it again, we'll do it when the time comes. So that becomes 2x, that becomes 15 dy dx. It's y is a function of x. We have to do, I guess that's a product rule, because that's still a function of x. So we'll derive the x first, and get 15 dy dx. Other part of the product rule, 15x stays there. And dy by dx, that's just y prime x. Y prime x itself will derive down to 1. That's the part where I'm a little sketchy on, but I think then chain rule, we just do d squared y dx squared. I think that's how you're supposed to handle that. Then we got another chain rule there. We get 2, deriving the y, we get dy dx times dy by dx again, so dy by dx squared plus, now we derive the dy dx, 2y d squared y dx squared equals 0. And now we can see that thing, plug in 1s for all y's and x's, and -1 now for dy by dx. So 2 plus 15 times 1 plus 15 times 1 plus 15 times 1 d squared y dx squared. It's not actually squared, but just the second derivative. So we're going to get a little quadratic here. So we do have a dy by dx in parentheses squared. Oh wait, no, I'm sorry, it's not quadratic at all. Dy by dx is -1. See, I'm gonna confuse all the notation with squareds. Times 1 d squared y dx squared. Okay. So now that's 32. Plus 2 is 34. Plus 17 d squared y dx squared equals 0. So d squared y dx squared equals minus 2. Subtract the 34 over divided by 17. Okay. Now you just plug that into the formula and you're home free, I think. Hey, SPQ. I think we know enough now to write back to this person. you only need to know dy by dx evaluated at 1, 1, and d2y dx squared. I mean, I can make this a bit shorter. Necessarily need to explicitly solve the equation for x or y. Recommend you use implicit differentiation, then plug in 1, 1, oops, for x and y. That'll get you the value for dy by dx. And solve for dy by dx. That'll be the prime x in the formula. And implicitly derive again to get d squared y dx squared, and again plug in for x, y, and what you just got for dy dx. Hopefully that helps them. Find the recurrence relation, the solution recurrence relation given the initial condition. I usually can't do these, but let's just look at it for fun. Using backwards substitution. Let's see what this is. Oh wow, this is they don't have any frills on this site. Let's see though. I can't get the subscripts in plain text. Oh. And so you end up with just a factorial of n. It's a bit of a simple case. Let's see if we can apply it to this series though. They know the answer. Well, what's part of the fraction is a little bit ambiguous, I guess, but let's at least try the technique here. I don't know if I'll be able to, I might get stuck, but let's just try it. Ugh, I did order a new eraser, so hopefully it doesn't take so much effort. This one might just have erased all that it can possibly erase. Or the marker maybe dries out quick. Okay, there we go. So we have a sub n is equal to a sub n minus 1 plus n. Oh, you know, this is just going to be Gauss's formula, isn't it? Astro, hey, 15 watch streak. Wow, thank you. The double whoa. Thank you so much for 6 months? Dude, that feels like it's been so long. Or like, it feels like it hasn't been that long. Thank you so much, though, Astro. 6 months. That's weird. That's weird to think about that I have people who've been sub for 6 months and even longer. Well, thank you so much for that. And Dudesworth, hey. Were you able to explore KM you see yet, or are you still waiting for your friend to hopefully get on? All right, so let me look back at the backwards sub thing. That cool new sub badge? Yeah, that's it's Delta. It's like a little sperm kinda. Although maybe I shouldn't have said that if you're saying how cool it is. He soloed it, he bailed on you. Oh, speaking of thanks for the follow. Just lurking again? No worries, Astro. Bailed on you. Ah, that sucks. At least he still explored it. Okay. Go to the temple finally? Ooh, that's exciting. So I think what we do here is we do, whenever we see n here, we do n minus 1. So that n becomes n minus 1. This n minus 1 becomes n minus 1 minus 1, which is n minus 2, plus n minus 1. And now we can plug, we know a sub n minus 1 is this, so let's plug it in up here. So we know that a sub n is equal to a sub n minus 2 plus n minus 1 plus n. Now we do the same thing with this. A sub n minus 2 now is equal to a sub n minus 3 plus n minus 2. And now we plug this in up here. A sub n is equal to a sub n minus 3 plus, wait, why did I write a plus 1 there? That's not right. Sub n minus 1 plus n. Wait, why am I crazy? There we go. It's just that, not all the extra stuff. Now we get all the extra stuff when we plug this in up there, though. Okay, so yeah, we're assuming we end up adding all the numbers up to n. A sub n is equal to the first term 1 plus 2 plus 3 plus dot 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 plus n minus 2 plus n minus 1 plus n. So this is really just like, you know, Gauss's formula, Gauss's summation, whatever, which is 1/2 n plus 1, if I remember right. Might be it might be n minus 1. I need to Google that. Hard locked. Suck my wiener. Hey, hard locked. You made an aubergine-based. I have no idea how you pronounce that. Let me look it up. Oh, I didn't even spell it right. Oh. Polish vegetable and sausage stew? That looks amazing. With aubergines, it might be a little weird, but... I mean, I've never been a fan of them, like that big a fan of them in the first place, but... It could still be good. You know, probably will be not exactly delectable. Hey, you know, it's still food. Okay, so let's see if someone else beat me to the punch here. Sure did. That answer isn't quite right as well. Gauss summation. And n plus 1 over 2. So I'm not sure they're not working towards the wrong solution. Yeah, so this person did just keep doing ends, but that's not right. Why is there the 1 plus? Was it maybe because a sub 0? Actually, I'm a little bit sketchy on that, because with the indices, it might actually be 1 plus that. Does the normal Gauss sum start from 1 or 0, I guess? Maybe I'm just gonna not jump in. They don't even say the index? No. Yeah, that starts from 1. I'm gonna leave it alone. It might actually be 1 plus it for this exact case. Actually, there's even a new comment. Okay, yeah. They said more or less the same thing as the other person. That is an answer. Oh yeah, no. Okay, this one I already looked at. Let's go to different subreddits. I got into the bottom of this one. Wait. Oh, never mind, Professor. I thought that was pause on my notes, and I was about to have a panic attack. But Professor Leonard is something else, I guess. What are matrices for? Oh, there's. I mean, it has 14 comments, but where do we get them? Why do we use them? The answer is yes. They are completely useless and stupid. Um, um, it would be doable if you were a sadist. I think they are useless. That's what I want to do. No one seems to agree with me though. They're all saying that these things are helpful. Okay, yeah, this is the stuff that I always think of. Like, I remember like, oh man, I don't remember what the context was. There was some kind of like presentation thing that the math department did at my university, and like, these one students talked about like linear algebra being applied to like computer graphics, and how when you rotate your phone and the actual like display rotates, that's a linear transformation basically. And that kind of was like mind blowing. Oh, of course it is, and I never even thought about that. So I guess I can't say that it's completely useless, but outside of the niche of rotating your phone, you know, it's completely useless. Okay, these all have answers. Let's look at mask math. This is linear algebra? What is this question? This is more of a physics thing, I would think. I think they think it's just. I think they think linear algebra is just like normal algebra with lines. But I have no clue how you. Oh, what the hell? So x sub a is a function of z, it looks like? I guess it is a. Well, Yeah, I don't know how you do that. I'm gonna let that person responded already, so. Boundary conditions look kind of cryptic. I didn't even look at those, to be honest. Z equals Z sub 1, X sub A sub... Oh, okay, yeah. Very general, I guess. Hey, Hypatia. How's it going? As an answer. You're so bored? Oh, that sucks. Wait, they're scoring animals? They're weighing animals? Or a weighted score? Do you care about micro-local analysis? I have no clue what that is. I feel like I wouldn't get it. I don't get what question I was looking at just there. Oh God. Wait. Oh, non-abelian derived function. Oh, I definitely don't get that. Explain just a single one from its section that would be helpful. Let's see what we're working with here. I don't know. This might be a little bit too much for me, but... Okay, well... This one section I can definitely explain. Because you basically have to draw a right triangle. Two, we got... This is algebra. It's going to involve inverse trig functions. This is going to be way too much to explain in a single Reddit post. More algebra. Okay, now we're bringing in identities. And there's the answers down there. Okay, so this is something where I'd rather link them to a resource. Globalizing calculus / differential equations in the sense that you don't consider a single generalized function. Okay, so I've heard of functors. Like, isn't it like a category thing or something like that? But I have a bachelor's in applied math, and I specifically avoided anything like algebra or analysis related, so I'm very like ignorant of it. Machine with sheath. Discovered first for algebraic geometry. Okay. Got some knowledge of algebraic geometry. Oh, okay. These aren't exactly the kind of problems that I want. See, you're out. Character theory is the most beautiful. I'll take your word for it. I don't know that the little bit that I do know of stuff like that, I just don't even slightly get it. Category theory study stream 1. That'll never happen. Oh my god. If I'm gonna do a study stream, it's gonna be like differential equations or something, or the real analysis from Zach's class, which I guess I've already been doing that, but. Oh yeah, so I think this site is gonna be pretty helpful to the person. Yeah, this is the kind of stuff that they... What? Go away. Okay, yeah, I think this is exactly what the person is going to need. Actually, wait, did they cover the whole drawing a right triangle thing? Kind of, but not really. So I'm going to explain that part in text, and the rest I'm going to leave to I'm not gonna say thereafter. Then the problems after involve algebra techniques and sometimes identities to find x. In regards to the first set of problems, I'll try to explain 1a as an example. Sine arctan minus 12 over 15. Or minus 12 over 5. It's Pythagorean triple with, I think, 4? Or something. Start by looking at the inside. Tan theta is equal to opposite over adjacent. Adjacent. So theta, so also theta is equal to arctan of opposite over adjacent. It's a Greek letter. I should explain what theta actually is. I don't know if they've even gotten that far. Actually, do they use theta or x? I should use x. Let's not even worry about theta. If they're already just learning the basic like trig manipulations, it's not trying to make it more complicated with getting Greek letters involved. I took the arctan of both sides, and arctan of tan of x is just x. Is this getting too complicated? I feel like I'm explaining the theory too much and not what they should actually do. That was entire like, okay, no. I don't like that. I want to at least get them going with problems and not worry about the theory that much yet. At the inside of sine of arctan minus 12 over 5. Without going too far into the why this works, start by drawing a right triangle label the right angle, then label either of the other angles x. Since tangent is opposite over adjacent, I just realized that we have to worry about where arctangent is defined, don't we? Because we need to know where sine, if the sine should be positive, or does it matter? If we have negative 12 over 5, which one gets the negative sign? That's what I'm trying to figure out, basically. And that's going to make the explanation a little bit more complicated. Hey, Enigma. Oh god, why is the camera shaking? Oh god, stop shaking. Okay, if I bounce my leg, is that gonna... Oh, okay, it doesn't make it shake. Okay, sorry for that. Earthquake, yeah. Audio's jittering too? Really? That's not good. Like the music or also me? I've had definitely the music jitter. Song shaking as well. Okay, I just paused it and unpaused it. That fixed it the last time. Is it still happening? But I'm fine. Okay. If the song's gonna keep on jittering, I'm just gonna not play music. Because that sounds kind of annoying. For me, it sounds fine, so I'm not sure why it's not coming. It's happened before, but I don't know why it happens on stream. It's still happening. That's annoying. It's probably better that I just not play music then. Thank you for telling me. It's annoying. So I remember when I was taking a trig class, there's this very convenient like unit circle that we drew, and like I think sine is in quadrant 1 and quadrant 4, and I think tangent is quadrant 1 and quadrant 4. Sorry, arcsine and arctan, and then arc cosine is quadrant 1 and quadrant 2, something like that. And actually that makes sense because you can't cross over the x equals 0 line. Yeah, okay. But then my explanation becomes less general for all these problems. And they do have an arc cosine. Thankfully, it's positive. So I'm trying to think of how I can like explain this in as general way as possible so it's helpful to them. I might want to draw a picture and link the picture. You missed an earthquake? The earthquake was me bouncing my leg and somehow shaking my cam. I think I need to draw a picture for this person. Which is okay. I just was being lazy, I guess, and not wanting to go through the trouble. Okay. I just feel like there should be some kind of more convenient explanation, but I can't think of one, so let's do it this way. Okay. Let's do blue. Okay, so we have sine of arctan of minus 12 over 5. Since tangent of x is equal to opposite over adjacent, x is equal to arctan opposite over adjacent. So the opposite, we want negative height, so we want negative 12. Adjacent is 5. Now we come down here, draw our axes. Ah. Really? Oh, so that's actually not, or it's 5, 12, 13 is the triple. Because 144 plus 25 is 169 is 13. Let me actually, I should actually say white. Okay. Oh shoot, I should label the angle x. There we go. Sine of x is opposite over hypotenuse. And so I guess I'll just write minus 12 over 13. And that's the answer. Okay. So let me go, I need to open up my own stream and take a screenshot. Give me 1 second. Okay, got my screenshot. The smudges on the whiteboard are showing up in the screenshot. Man, I can't wait for my new eraser to get here, so hopefully there won't be as many smudges. Okay, I got my screenshot. Let me upload it to Imager, then I'll show my browser again. Now, is it going to mark it as 18 plus for no particular reason? Nope. Okay. Um, I mean, how do I explain this in words now? Okay, okay. Draw a right triangle with x and y, with an x and y axis, or with x and y axes. One of the sides should always be along the x-axis. Label the angle by the origin as x, or whatever letter. Because we have arctan minus 12 over 5 on the inside, and tangent is opposite over adjacent, the side across, or the side opposite x, should be minus 12, or i.e., go 12 down, and the side adjacent x should be 5. Go 5 right. Having a negative on the inside makes it a bit trickier, but the rule is that for arctan and arcsine, it's negative. We draw the triangle in the lower right, and for arc cosine, you go upper left. So we've drawn a right triangle and know two sides of it. We can use the Pythagorean theorem to get the third side. Just type out the Pythagorean theorem actually is, so I guess they don't even know that much, which we all have to start somewhere. It's 13. Now we know every side of the right triangle. And just need to know what the sine of it is. Sine is opposite over hypotenuse. So that's how you spell hypotenuse, isn't it? Oh, there's no extra, I put an extra E, I guess. Okay, never mind. Minus 12 over 13, and that's our answer. Okay, bit of a long explanation, but I think this is hopefully enough to get the person where they need to be to solve these 4 problems, I hope. I'm kind of assuming that they know a few things on their own with how the trig functions all work, like cotangent. But we can always let them reply and we can give them more information depending on how they respond. The explanation is going to get very long if I also try to go through the algebra problems. So I'll stop there for now. Let me know if you have a question on the above to at least get you started. On the others, there's also this site has many. Oh shoot, the link doesn't work. Look at all that stuff. It's because of the parentheses. Bam. Bam? Good. Now the link works. Bam, putting parentheses in a URL is kind of evil. It's many examples. The same type of problems. I may look in the Trig identity worksheet too. Identities that you'll need for some of the problems. In particular, the ones involving cosine of 2x. And I'm completely also glossing over like the whole them being periodic. Cause like I noticed they're given intervals to give their answers over. And some of them were like negative infinity to infinity. So they're gonna have to learn the answer plus 2 pi n thing. Or maybe adjusting it for your period, but I don't want to get into that stuff yet because this is already 4 paragraphs. So let's just leave it here and see if they get back to me. All right, so that's where I just was. Let's keep looking down. Never mind, we're at the bottom. Alright, so we're at things that I've already seen. Okay, so let's go look at the math Discord. Okay, let's see if we can get some questions off here. Oh! What is this? It's infinity minus infinity. This one just looks kind of fun. I don't care if someone replies back to me quick. I want to see if I can figure this one out. I assume you have to rationalize it.